I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss some excellent questions based on factoring. We'll factor polynomials. My questions have been taken from previous test papers, and students normally find them difficult. The 5 questions which we are going to discuss are shown here. I would like you to pause the video, try them out, and then look into my suggestions. These are of different kinds. In the very first one, we are going to use product and sum method. To factor the polynomial. In the second one, we'll use substitution. And then factoring. In question number 3, we are going to use difference of square. Question number 4 actually is unfactorable. So I'll share with you a technique to factor that also, right? So how do we factor unfactorable? That is critical to understand. Now in question number 5, it is one of the most difficult questions which we have come across, and here we are going to use synthetic division. And of course, factor theorem. So with that, you will see how some typical factor related questions can be factored. So here is question number 1, which is kind of simplest of all of them. Let us see how do we factor this. The question is 2 times x plus a whole square plus 3 times x plus a plus 1. So it is a very normal question. You can substitute u as x plus a. In that case, it becomes 2u square plus 3u plus 1. Do you see that? So now it is a very basic question which can be factored using product and sum. So we are looking for product of two numbers to be 2 times 1, which is 2, and the sum of two numbers as 3. Well, the two which satisfy this will be 2 and 1. So I can write the given trinomial as 2u square plus, split this as 2u plus u plus 1. And now we can factor by grouping, as you can see here. Do you realize? So taking 2u common from the first two terms, we get u plus 1. And here we already have u plus 1, right? So that gives us u plus 1 as one of the factors and 2u plus 1 as the other factor. And now we can substitute back x plus a for u. So we have x plus a plus 1 times 2 times x plus a plus 1. And this gives you x plus a plus 1 times 2x plus 2a plus 1. And that is how we are going to factor it. I hope you have understood the technique. Very simple. We substituted x plus a as u and then we did it like normal factoring. Key is to substitute right variables. Here is question number 2. 10 m to the power of 6 minus 7 m cube n square minus 12 n to the power of 4. To factor this, we observe m square n square term in between, and they kind of give us a hint. We can substitute m cube as equal to x and n square as equal to y. In that case, m to the power of 6 will be x square and n to the power of 4 will be y square. So this substitution will help us to factor. So from the given trinomial, we get 10 x square minus 7 xy minus 12 y square. Do you see? Now it becomes a simple trinomial which you can easily factor. Now in this particular case, we're looking for product of two numbers to be equal to 10 times 12 with a negative sign, correct? And the sum of two numbers as minus 7. So 120 and minus 7. What two numbers can we use? So we can trial and error. We're looking for the numbers which could be product of 10 and 12. So the two numbers which can really work with us are 15 and 8. So 15 and 8, how do we get these numbers? So 10 could be written as 5 times 2. 12 can be written as 4 times 3. Now here you can make a combination as 4 and 2, 8, and 5 and 3, 15. Do you see that? So by factoring the individual terms, it becomes simpler. So what we could have here is, since we want negative 7 as a sum, negative 15 and plus 8 can work for us. Perfect. So we can now write this as 10 x square minus 15 xy plus 8 xy minus 12 y square. Now in the first two terms, 5x is common. So we can write this as 2x minus 3y. And now here, 4y is common. So we can write 4y and we get 2x minus 3y. So 2x minus 3y is a common term, leaving 5x plus 4y. Now substituting back, x is m cube, I get this as 2m cube minus y is n square, 3n square times 5m cube plus 4n square. So we have factored the given trinomial with the help of substitution. You also see a very special technique. How did we find the product and sum combination? The idea was to factor further the 2, 10 and 12 product, which gives you 120 as the product, and figure it out. Perfect. So I hope this strategy is absolutely clear. Now, let's have a look at question number 3. Question number 3 is 9x square plus 6x plus 1 minus 4y square. The strategy adopted here will be the first three terms are a perfect square. Let's have a good look at it. We could write this as 3x whole square plus 6 is 2 times 3 times x plus 1 whole square minus 4y square. Clearly, you can see that the first three terms can be written as 3x plus 1 whole square, and we have here minus 4y square. Now minus 4y square is 2y whole square, correct? So basically, if you see it carefully, it is difference of squares, right? This is 2y whole square. So we can write sum and product. And what we get here is 3x plus 1 plus 2y times 3x plus 1 minus 2y. And that is how we can factor it. Let me just rearrange to write the xy terms first and then the constant 1. So we have 3x minus 2y plus 1 as the other term. So that is how we are going to factor this polynomial with 4 terms. I hope this step is absolutely clear. Here is the next question. I actually put this under the category of factor the unfactorable. So here we write factor the unfactorable. Why it is not factorable? Because if you do sum and product combination, you can't get the right one. 9 times 4 is 36, and we cannot get product of two numbers whose sum is 8 and product is 36, and that is why we cannot do it. So here is a special technique. It is like completing the squares. Let us see how it works. See, 9x to the power of 4 can be written as 3x square whole square. That is 9x to the power of 4. Now 4 could be written as 2 square. What we need in the center is 2 times these two terms. That means we need 2 times 3x square. You get the idea. If we have that in the center, we can factor this as a perfect square. However, what we have is 8x squared, and this is what? It is 12, right? So if you multiply these numbers, you actually get 12x squared. We need 12x squared. We have 8x squared. What can we do? Well, we can add 4x squared and we can subtract 4x squared. You get the idea. Then you get that term, correct? So that is the whole idea. So what we are doing here is that we have 8x squared, and to make it 12, we are adding 4x squared. So now we can write this as 3x squared whole square plus 8x squared and 4x squared is 12x squared plus 2 squared minus 4x squared. Do you see that? So basically, these three terms now become a perfect square. And therefore, I could write this as 3x squared plus 2 whole square. And here we have 2 times x whole square. We can now apply difference of squares. And we get what? We get 3x squared plus 2 plus 2x times 3x squared plus 2 minus 2x. And that is how we are going to factor it. Let me just rearrange it. 3x squared plus 2x plus 2 times 3x squared minus 2x plus 2. And that is how we can actually factor unfactorable. The strategy was that we checked the center term. We needed 12x, right? We need 12x squared. So to do that, we added and subtracted 4x squared. Adding and subtracting the same term is like adding and subtracting 0, which does not change the equation. So I hope this concept is absolutely clear. Now here is the last question, which is question number 5. Px cubed plus p minus q x squared plus minus 2p minus q times x plus 2q. How do we factor this? Now, this is a polynomial of degree 3. Earlier, we learned techniques which could solve quadratic equations factoring. Here, we need to figure out what will give this a 0 value. Let us say this is a function f of x. In that case, we're looking for a value of x which will give us a 0. Now that could be factor of 2q. So what are the factors of 2q? Factors of 2q could be plus minus 1, plus minus 2, plus minus q, right? Even plus minus 2q. If you go deeper into factor theorem, we also need to divide them by p. So there are many combinations, right? There could be 1 over p plus minus 2 over p plus minus q over p plus minus 2q over p. So these are all the possible combinations which can work for us. Let us try one by one. So if I substitute 1 here, then what do I get? 1 for x, right? So we get, substituting 1 for x, we get p plus p minus q plus minus 2p minus q plus 2q. And that gives us, let's open this bracket, p plus p, let's read out, p plus p minus q minus 2p minus q plus 2q. And that gives us p plus p is 2p, 2p minus 2p cancels, and as far as q is concerned, that also cancels, and we do get a 0. So for 1, we get a 0. It really means that x minus 1 is a factor. So I could now divide the whole thing by x minus 1. You get the idea? So I can divide the whole thing by x minus 1. What am I dividing? Px cube plus p minus q times x squared plus minus 2p minus q x plus 2q. So to divide it by x minus 1, we have to take the first two terms and we could go for p x squared. That is the process of long division. You could also do synthetic division at this stage. So multiplying by px squared, we get px cubed, taking care of the first term, minus p x squared. Now taking this away, what do we get? So we have px squared minus of minus px squared gives us 2px squared, and we have minus qx squared. Let's bring down the other term in x, which is minus 2p minus qx. Now, x squared is common. We can multiply by 2p minus q. So the next term will be 2p minus qx, so that we cancel away these terms. When you multiply this by x, we get 2p x squared minus qx squared. Let's multiply this with minus 1. So we get minus of 2p minus q times x. So now when we subtract, you get minus 2qx and bringing down plus 2q. Now we can actually multiply this by 2q, right? So minus 2q. So if you multiply by minus 2q, you get minus 2qx, and that becomes plus 2q, and so the remainder is 0. So we get a quotient of px squared plus 2p minus q times x minus 2q. Do you see that? Now we have to further divide or factorize the quotient to completely factor. So let me write down this expression, which is px squared plus 2p minus qx. Let's write down. So we got this as equal to x minus 1 times px squared plus 2p minus qx minus 2q. So we have partially factored this. We can actually factor this quadratic equation also. So we tried 1. Now let me try some other number to factor this. It could be a factor of minus 2. So let's try the value for 2. So if I substitute to factor this, let us say for x, we substitute, let's call this as g of x, right? So we are substituting 2 in here. So if I substitute 2 here, what do I get? I get 2 square as 4, 4p, plus substituting 2 here, we get 4p minus 2q, and substituting 2 minus 2q. Well, that gives us 8p. So that doesn't work. Let us substitute minus 2. So if I substitute minus 2 here, I get 4p minus 2 will make this as minus 4p, and minus 2 will make this as plus 2q, and we get minus 2q, right? Which is equal to 0. So we do get a 0 here, right? So earlier we had minus 4q, correct? So since we have a 0, that means that x plus 2 is a factor. So we can now divide this by x plus 2. So dividing by x plus 2, let me make some room here. We have px squared plus 2p minus q x minus 2q. So x plus 2, that means taking care of the first term, I have to multiply by px. So we get px squared plus 2px, and taking the difference, we get minus qx left. Here we have minus 2q. So we can now multiply by minus q. Will result into qx minus 2q, which is 0. So we have factored this, and therefore we can write the given equation as product of x minus 1 times x plus 2 times px minus q. Do you see that? That is how we can factor the given equation. So all these examples which I have taken, they are actually very challenging questions, especially the last one, where we have used the factor theorem and a lot of techniques to factor the given polynomial. I hope you find this interesting and useful. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.